Welcome back to some more hypotheses testing. So in this first scenario today, a shop normally sells 5 iPhones per day. The shop decides to reduce the price of the iPhone by 5%. In the first 2 days after the price change, 16 phones are sold. So as in any situation, if you are a shop or anything and you decide to reduce the price or increase marketing, you or hire more people or whatever you're going to do, or increase staff training, you want to test, okay, has what I've done, my investment, my price discount, made an overall impact on my sales? So has my price reduction by 5% actually led to an increase in sales to 16, or is this 16 not an unusual result normally anyway? Okay, well, the first thing to decide is the type of distribution. Now, per day, so the per part, this is a rate of the rate is 5 iPhones per day, which means we're looking at a Poisson distribution. Okay. So looking at rates and the Poisson distribution. So establish the null and alternate hypotheses is our first job. So the null hypothesis is that under a normal condition, that this is not an unusual result, that the rate of the phones sold has stayed the same. So in this case, that, remember in Poisson use lambda, the lambda is going to stay the same, which is 5 iPhones per day. So our null hypothesis is that the rate hasn't changed. However, what if it has changed? Well, we'll be looking at, what do you think? The rate the phones have sold has increased. So how do you write this? So it's our alternate hypothesis. Again, it's lambda. And we're looking for an increase. So the rate would have gone up. So there is, we've established our null hypothesis that our rate has not changed. The normal condition is the rate hasn't changed. However, we're going to test it, and if there's evidence to reject that, we're going to assume that the rate has actually increased. Now, step 2 is always decide odd significance level. Now it is given to us somewhere, so we go 5% significance level. So, right, so 5% significance level. Collect data, well, that's already given to us. We have 16 phones that are sold. So let's establish what our distribution is at this point. So let's, okay, so our parameter right, so x, define x as number of phones sold in 2 days. Why not 1 day? Well, it's in 2 days because our data is about a rate over 2 days. So we're looking at the probability. Okay, let's just define the distribution. So x is Poisson. What do you think the rate is going to be? So it was 5 iPhones per day, but now looking at 2 days worth of data, so the rate over 2 days be 2 lots of 5, which is 10. So really just be careful that the data matches or given as our rate, and if it doesn't, the rate needs to change, not the data, the rate changes. And at the 5% significance level. So alpha is 0.05. Okay, our test. So your test, is this an unusual result? So, the probability that x, there is always an inequality. It is always an inequality. So we want to see, is x particularly high, or in fact even, or is 16 rare, is 17 rarer, 18 rarer is rarer than that. So it could be bigger than. We don't have this in our tables. Oh no, we do actually. My mistake. It is in our tables. Just seen it. But our tables only give us a case where it's less than or equal to. We did a number line from 14, 15, 16, 17, 18. So we're looking for this. So the reverse case would be the chance that it's going to be 15 or less. So I'm going to do 1 minus the probability that x is less than or equal to 15. And that is in our tables under 10, and 15 is 0.9513. So 1 minus 0.9513. That's 0.0487. So the question is now to you. You did our test, now to interpret in relation to the original problem. So are you going, is there enough evidence at the 5% level to reject our initial hypothesis? Well, there's 5%, and this value is 4.87%, which is here. So under normal circumstances, it is quite unlikely to get 16 sales. So therefore we can write that there is evidence at the 5% significance level to reject HO and to suggest that the rate of sales has increased. So there's evidence at the 5% significance level to reject our null hypothesis HO, and to suggest that the rate of sales of the phones has increased. Now it's your turn. What I want you to do is to have a go at this question, and then you can come back and see my answer, which I will upload in a second video. So have a go at this first, give it your best shot. It might take a couple of attempts, but give it a go. Then you come and compare your answer to what I came up with.